common operating system. And so for us to do that, we look at those machines. We don't look at them as individual machines. We just look at them as one operating system. It just happens to be 33 machines. And so we have a few hundred cores, terabyte of RAM, and numerous terabytes of storage that we can take advantage of. And so just like I don't tell Outlook which processor to run on when I open it on my laptop, I want to run a 10-node Elasticsearch cluster. I don't really care where it lands on what machines. I just want it to run. And so that's the concept of having a data center operating system. And so in the industry, this is powered by Apache Mesos, which you might have heard of before. It's been mentioned in a few other sessions today. But Apache Mesos, I'll deep dive into what it is in a minute, allows you to treat a bank of machines or a pool of machines as one common operating system. And DCOS provides the operating system on top of that to be able to schedule work to run. So this isn't something that we just found and started to use. This is something that's been industry proven for a number of years now. If you've ever talked to Siri before, there's a 60,000 node DCOS cluster underneath that, or Mesos cluster at least, that's answering your question. If you've done things with Netflix and other things, there's lots of these organizations are using these in production for numerous years. So it's proven, it's not anything new. We're adding Esri as a partner into this. And so what we've been doing inside of Esri is this project that we call Trinity. It's Trinity like the Matrix character. It's not Trinity like Christianity or Trinity like the atomic bomb thing. And as I travel the world, Trinity is like the worst project name ever. So I always qualify it now with the Matrix character. But Esri's partnered with Mesosphere, who's the company behind Apache Mesos and DCOS, to deliver these solutions for these customers that require this scale. And so what we've had in the past is something that looked like this, where we had our products and they kind of ran in one process on one machine, and they only scaled up to a certain level. And so this would only give us thousands of events per second and being able to store and visualize millions of events per second. And our requirement from these customers was to move magnitudes higher. So to go to millions of events per second and be able to store trillions and visualize trillions of observations that are being stored here. And so for us to do that, we couldn't just take our software and say, okay, run our existing software on DCOS. We had to containerize. And so we containerized our applications. We broke them apart into their logical microservices or logical units that we could deploy them in. And so what that looks like is we took our products and basically broke them apart so that we could scale any aspects of those products on any dimension. And we'll talk more about those dimensions in a bit. So these are the microservices that we deploy when we deploy to a Singapore or Dubai type of deployment. And these are the technologies underneath them. So you'll notice nothing too groundbreaking here. These are all the technologies all the other sessions have been talking about. It's just that we're bundling all this together onto one cluster and delivering it using DCOS as a really efficient way to deliver these services so we can make the most use of the resources that we can. So a deployment might look something like this, where there might be 480 cores, a terabyte of RAM, and 30 terabytes of storage. And when we deploy this out, we scale the different aspects of those services as big as somebody needs those. So if it's Singapore tracking every car in the country, then we might need lots of black source ingestion tasks to be able to read millions of events per second. We might need 5 Kafka brokers, and we might be doing some analytics in the stream with our real-time analysis tasks. We might need multiple services running at scaled out at different levels, and then our storage could certainly be whatever is needed as well. So that's the point where I'm going to stop talking about Esri-specific stuff and start talking more generally about the technology. And so what we've done to do that is, I guess one last note, is that our customers require this to run in lots of different environments. It's not just that we can say, go deploy this on premise and we've solved the problem. It's that we need to be able to build this software once and be able to run it on premise, be able to run it in a private cloud like Amazon C2S, that's like a gov cloud type of thing in the US, or like a public cloud like EC2 or Azure. And so we don't want to write our software differently to deploy to those different applications. We want to write our microservices and containers once, be able to deploy those with some configuration changes to those environments. And so this is the point where we actually step away from the Esri-specific pieces, and I've written this GitHub repo, this Dcos Iot Demo. I did this about a year ago. We unveiled this at the MesosCon keynote last year. And I've been undergoing a number of revisions for this session and for the upcoming MesosCon. So still a bit of a work in progress. But what I'll show you is a quick video clip of the end result of this, and then we'll deep dive into how it actually works underneath and how it's configured. Okay. So this is an app here. This is, I'm sending in taxicab simulated data that we've captured from New York City. This used that taxicab data set that some of you might be familiar with. And what we're looking at is these numbers will be changing on the fly here. And as we change the symbolization technique, we can render things in an aggregate view. So the 108 there means that there's 108 taxicabs currently at that location. And as we zoom in, we can actually see the raw observations. So our map is basically switching between an aggregate view and a live feature view. If you watch the dots close enough, you might see some new dots appear. And what we'll do is zoom out here and actually go into some study area like JFK. And what we might want to do is interact with this data. And as we zoom in here, you'll see new tracks appear towards the front of this. So this is a live system. We can identify who is that taxi, how many passengers do they have, or we can identify another taxi that's down here. So this is taxi ID 211, taxi ID 190. And so we can interact with this data in a live capacity, and we can also look at it historically. So this is the concept of having the space and time database, where we can query this really efficiently, go back, replay this data, and maybe make it more specific, like I'm only interested in one specific taxi ID. And I can go back and play that one specific taxi ID, or remove that where clause and look at the 3 taxis that are currently active in that location. And so this kind of gives you an idea of how rapid this data could be. I think there were a couple 100 million observations in this data set that we were looking at. This is just a small clip of it. As we go in here too, we might want to do some spatial analysis. And so this is like an Uber type example where you might want to notify a passenger whenever they need to be picked up. And so if we drill in a little bit closer here, what we'll see is our distressed passenger doesn't look very happy. What we're doing here is actually deploying another application to DCOS, and that's going to make that vehicle move over there. It's basically sending data in through a source, Kafka's receiving that, and then our real-time analysis task is storing that, and then we're rendering that on the map. So this is all happening very fast. And so we can see that vehicle coming through. That red shape represents exactly 1 minute drive time away from that person. So we're looking at the speed limits of the road segments and calculating a polygon that represents exactly 1 minute away. That could change. So the traffic conditions could change and that shape could change. And if it changes, then we just get a new shape. And so this guy gets happy now because his car is coming to pick him up, and he gets picked up and goes on his merry way. So this is a very abbreviated version of what's on the repo. I would suggest to look at the repo. I have a finite amount of time here for this session. So how does that all work underneath? Well, there's all of the things that are at the bottom there that are deployed to make that work. A little bit of history is that we've kind of been through this physical to virtual world, and now we're kind of entering this, what Mesosphere calls the hyperscale world, where we need to be able to scale out and scale out significantly. And so this applications for this are things like IoT and big data and mobile apps that kind of get widespread very quickly. The delivery model for a lot of these things are containers and microservices, as we've kind of been talking about. And this really is a new form factor for delivering these apps. A little bit more history is that a lot of you are probably familiar with Linux, hopefully. And there's a kernel for Linux, and there were a number of operating systems that were built on top of that kernel. And so just like there was a kernel for Linux in CentOS and CoreOS, Red Hat, Ubuntu, other OSs that were delivered here, Mesos is a kernel. It's a distributed kernel that runs on multiple machines that make multiple machines look like one machine. And if you take these things that we were talking about before, where you have CentOS running on top of a Linux kernel, we have a bunch of machines that are provisioned with CentOS and the Linux kernel. What Mesos does is it basically puts a distributed systems kernel on all those machines, and it basically makes all those machines look like one logical unit. And so it has different roles for each of these machines to play. They can be public agents or private agents. So those agents are things that are compute resources. So I'm going to run and schedule work to run on those. Public agent is accessible to the outside world, whereas a private agent is locked inside a virtual network inside that nobody can access. The scheduling and resource manager is responsible for making decisions about how to schedule the work. And so what's actually running here is it's a multi-master setup for high availability. It uses Zookeeper as its quorum, and then that Zookeeper elects a leader, and then as you schedule work to run here, it schedules the work onto these different machines. Dcos runs on top of Mesos, just like Ubuntu is an operating system for the Linux kernel. Dcos is the operating system for the Mesos distributed systems kernel. And this Dcos provides you a package repository. They call it the universe. And this allows you to deploy new things to the environment here. So I can start to deploy like Elasticsearch as a capability on here, or Kafka, or Spark, or other things. And it has two major concepts at the top right there. There's this little spinning disk looking thing that's called Marathon. So Marathon manages long running applications. So this would be like a database or like a Kafka broker. It never stops, it just keeps going. Then there's also the little M, which is metronome. So it's metronome like if you were playing the piano or an instrument. So metronome is a distributed cron job scheduler. And so this allows you to do a cron job. So every Tuesday, run this thing and then destroy it. And so it spins up containers and destroys the containers and runs those. And so you provision the work and schedule the work to run in these environments, and you can do anything you want. So you can take any Docker container, any Rocket container, any other type of container that you want, run that inside of here. It's not specific to Docker. It has multiple containerization capabilities. So that's the concept of what Dcos is. And so what we want to do is, through the Dcos Iot demo that I posted out there, it kind of walks you through step by step. How do I do this? So if I wanted to do this for Azure, the first step is to provision the resources. This is really the only step that's specific to the provider that you're using. And so in this case, if I'm using Azure, and I apologize, the font's probably too small, but it's not really important that you read the specifics. What basically happens is I've built this template that's an ARM template. That's the Azure Resource Manager, so it's kind of like a CloudFormation template, if you're familiar with Amazon. It basically just asks you how many masters do you want, how many private agents do you want, how many public agents do you want, and then what size of machine do you want for each of those. And basically what you get as a result of that is a whole bunch of machines that are provisioned. And then you also get this boot node, and the boot node is how you actually provision the software to this environment. And so we copy up our certificate file, we copy up our Dcos installer, which is part of the repo that I published. And then once we have that installer, we just simply SSH into that machine, run the installer, tell it how many masters, private agents, and public agents we have, 353 in this case. And then it asks you, what do you want to install? Install the latest community edition of Dcos or a specific version. And then a few minutes later, you get this software provisioned to here. So it takes about 3 to 5 minutes to provision the Azure resources, the actual machines. It doesn't matter if you're provisioning 5 or 300. We do it all the time. It takes about 5 minutes to get that many machines available. And it takes another 5 to 7 minutes to install Dcos. So within about 12 to 15 minutes, you can have a full Dcos environment, 300 node cluster using these scripts. So it's quite powerful, because once you have the basic Dcos in place, you have a dashboard that looks like this. And this was a very small cluster because I didn't want to cost my company a lot of money to make screenshots for this session. But it's 50 cores and other things. But usually we see hundreds or thousands of cores in these cases. And so what we can then do is start provisioning our services and applications to this environment. So I can say I want a 5-node or a 5-broker Kafka system. And what I can do is, this is the universe for Dcos. I can go through here and browse the package repository that's here. And these are just the selected ones that are for this month. But I can just scroll down and see all kinds of other things. So if I don't want just bare bones Kafka, I want the Confluent Kafka, I can select that one. Or maybe I want the schema registry from Confluent to accompany my Kafka. I can install that in addition to this as well. So in this case, we're just going to select the Kafka one. There's all kinds of other databases here. There's Mongo, there's Postgres, there's Cassandra, there's all kinds of other databases that you can install here as well. We can install the Kafka. If we click on Install Package, you get all the defaults. Probably for development, that's cool, but for a production system, you're going to want to like adjust the settings. And so if we go into the advanced installer, you get all the different configuration settings. This is where you kind of need to know what you're installing. So you need to know about Kafka, what a broker is, and what the executor is, and those types of things. And so you can go here and you can say, I want a count of 3 or 5 or however many you want, so the count's at the top there. You just adjust these properties around. And then before you install it, there's this nice little download JSON file thing. So if you don't want to have to go enter all that junk in again, you can download the JSON file and then just go, here, admin number 2, run this on this cluster, and they'll get the same settings you have. And then success, you get this installed. If I go back and look at my dashboard, cool, look, my operating system, which is a bunch of machines, has 5 cores that are in use now. So they've been allocated for work. And if I drill into that a bit more, I can go into the services and see that there's a Kafka service running. And if I click into that, I see that there's 3 brokers running, and then there's a scheduler that's running alongside that. And you notice that they landed on different hosts, so the IPs are all different. So you can put scheduling constraints in there to say, don't put these on the same machine. You can go into lots of specifics on how it actually does the placements. There's also a really cool CLI, a command line interface for DCOS as well. So you can go in and connect to a DCOS cluster and then start asking it questions. So DCOS Kafka, do you have Kafka installed? If it doesn't, then it'll tell you that. Otherwise, it'll say, give me a broker listing. Okay, there's 3 brokers in this cluster. Give me the addresses of where the brokers are actually running, so I can see the DNS entries that are inside of here and what IPs in the address space are actually allocated. There's also this VIP, this VIP, which is the virtual IP. So DCOS and Mesos assigns a virtual IP to the service as well. So if you have a producer or a consumer that wants to access this, you wouldn't really access it through the 3 broker 0, broker 1 URLs. You would access it through the VIP. And so if a broker 1 died and happened to spin up on a different node, the producer and consumer wouldn't care about it. It would just access it through the VIP. And so this virtual IP gives you a point of abstraction where you don't have to know the specifics of what's happening. You would go through the same process to do Elasticsearch, to do Play, which is our reactive app that we deploy inside this environment, to deploy Spark. These are Spark streaming jobs, and then our sources that are actually going to be emitting the taxi cab locations. So the sources write to Kafka, Spark streaming reads from Kafka, Spark streaming writes to Elasticsearch. The Play app reads Elasticsearch, and there's a client app that's basically refreshing the map every few seconds, as we saw in the demo. So I think that's our 25-minute mark. I wanted to make sure we had time for questions. Here's a couple links to the various things that I've talked about here. The Dcos Iot Demo is the repo. Give me about another week and I'll have it fully updated. I wanted to get it done before today, but I had some personal constraints that didn't allow me to do that. But give me another week and I'll have that fully updated. And then at the bottom is a ton more information about IoT. So if that blueprint was interesting to you, go check out the content there. It goes into a lot more specifics. I'll be posting videos up to that bottom thing over the next coming weeks as well. And those links are at the bottom there too, and that's my contact. This is pretty cool stuff. Yeah. Question?
So you have like thousands of IoT devices. Do you connect them to that VIP, or how does it come ingest into your?
So the question is, if I have thousands of devices out there, do I connect them to that VIP? That's certainly one option. Typically, in an IoT space, thousands of devices might be manageable that way, but you would have a gateway that's actually sitting in front of all that, like an IoT gateway of some sort. So that's where like Azure IoT, Amazon IoT, Cisco IoT, these different solutions provide good solutions for that. Like in Azure, there's Azure Event Hub, and there's equivalent things in other providers. But that's specifically what those are for. The other challenges of connecting it directly to Kafka is how do you know that that's actually device 122? Maybe somebody's spoofing device 122. So a lot of these device management gateways provide bidirectional authentication, so you know that it's that actual device. And that becomes important when you're dealing with autonomous vehicles that you want to shut down remotely, or am I actually shutting down the right thing? Or Yep.
So earlier you mentioned that you now require your clients to build out, deploy this Mesosphere architecture. So I'm trying to get a sense of how much of the responsibility belongs with, in this architecture, Esri, with the client, and with Nessus?
So the question is, what's the prerequisite for somebody to deploy this application? So we provide multiple options at Esri. We provide a full managed service offering where we'd actually come in and lay down everything for a customer. And then we have other like defense agencies and folks who we work with that already have this environment, and we just come in and deploy our applications to it. So it really kind of depends on the opportunity that we're working on. We're also working on deploying this as a SaaS offering. And so there's nothing to lay down at all. So they would just come to arcgis.com or esri.com and say, I want to listen to Waves data, and when this happens, do this. And we would just do that. That's kind of our bigger plan for this architecture is to deliver that.
So they could have their own internal already deployed Mesos architecture.
That's right. Yeah, if somebody already has a Mesos here, we would say we're certified to run on Dcos 1.9 and just have to be up to spec for it. In the very back.
Established protocol for any random IoT device to connect to your infrastructure?
So the question was, there's lots of different IoT devices. Is there a standard protocol to connect to this? So it's the Wild West in the IoT space right now. So this is where a device management solution from these IoT platforms like Azure or Amazon could become very valuable. So we talk lots of different protocols. We can talk MQTT, we can talk AMQP, we can talk all kinds of different protocols, but then there's variations within device implementations. And so that's where these other IoT platforms kind of, there's even very vertical specific IoT platforms like ThingWorks and other things like that that have very specific deployments. So we're kind of agnostic to the devices, and we just plug into whatever IoT platform or device management people want to do. That's proven to be a good solution for us because we're not in the device management space. Yes?
Payload is connected to intelligence. How do you cover that?
So the payload it comes in a certain format. So when we receive it off that gateway, we have a canonical format that we have. It's still very generic, but we have a format that we can understand. Yeah.
Regarding the Mesos, so it's, you mentioned that's a kernel. So it's like a modified version of Linux, or that's something that's built from scratch? And if it's built from scratch, what is the hardware support for on-premise hardware?
I don't know the answer. So the question was, is what's the Mesos kernel? Give me more specifics about like what the implementation is. So there's a Mesosphere booth outside. I suggest to talk to them. I don't want to tell you the wrong answer. So I just use Mesos. I don't really know the internal details of it. So I don't want to tell you the wrong answer. I can tell you it's awesome as a user. Last question.
For the demo, when you play back the code, is it like sometimes Kafka, we read the stream, or is it sometimes database behind the scene?
So the question is, when we did the replay, is it Kafka or something else? So it's a direct connection to an Elasticsearch database that's indexed by space and time really optimally. All right, cool. Thanks for your time. I'll stick around in the hallway if you guys want to talk.